Okay, I'm going to make a series of short videos, one video for each of the problems on the practice exam. I'll try to do an example problem from Chapter 8 as well. So the practice exam I distributed was the exam I gave in a previous version of the course, and it covered a different set of chapters. So problem 1 was actually related to Chapter 4, which is not on our exam. Our exam is going to cover chapters 5 through 8. And I covered chapter 12, but I will not be testing you on chapter 12 on the exam. That's on linear regression. Problem 2 is related to the material in chapter 5, though, on joint probability and joint probability distributions. So let's actually take a look at that. So in problem 2, you're given the joint PDF for two random variables x and y. And in part A, we're asked to find the marginal PDFs. So let me switch over to a whiteboard here. So this is problem 2, fx and y. The joint PDF is 1/2 x 1 plus y for x between 0 and 1 and y between 0 and 2, and it's 0 everywhere else. In part A of this problem, we're asked to find the marginal PDFs. So the marginal PDF for x, we integrate the joint PDF over y. Okay, sometimes this is called integrating out a variable. So in this particular case, since our joint PDF uh, um, is a function of both x and y, a product of terms here, since the integration is over y, I can actually pull the 1/2 x outside the integral, and then also reduce the limits on my integral because y is, or the PDF, joint PDF is only non-zero for y between 0 and 2. So I'm left with 1 plus y dy. So 1/2 x again, and then integrating 1 with respect to y, I get y, and integrating y with respect to y, I get 1/2 y squared. I want to evaluate this at 0 and 2. Evaluating this y term at 2, I'm going to get 2 plus 1/2 of 2 squared. 1/2 of 2 squared is 2, so this term becomes 4, and then multiplied by 1/2, I'm going to get equal to 2x. And then evaluated at y equal to 0, this term becomes 0, the whole term becomes 0. So the marginal PDF for x is just equal to 2x. Follow a similar procedure for the y marginal. Now we integrate the joint PDF over x. So now I can pull out the term just involving y. Actually, I pull out the 1/2 as well, and reduce my limits. Now the joint PDF with regard to x is just non-zero for x between 0 and 1, and I left with just integrating x. This will be, of course, 1/2 x squared. So I'm going to get 1/4 1 plus y x squared, evaluating at the limits for x of 0 and 1. Evaluating x squared at 1 is 1, of course, and evaluating x squared at x equal to 0 is 0. So this just becomes 1/4 1 plus y. Okay, for the two marginal distributions. In part B, we're asked the question, are x and y independent? Why or why not? Well, one definition of independence is the two random variables are independent if the joint PDF is equal to the product of the marginals. Okay. In this case, that product is, got 2x times 1/4 1 plus y. 2 times 1/4 is going to give me 1/2. Then I'm left with x and 1 plus y. So the product of the marginals is equal to 1/2 x times 1 plus y, that is equal to the given PDF. So in this case, the answer is yes, they are independent. And again, the reason is that the joint PDF is equal to the product of the marginals. Let's see, moving on to part C. Find the probability that x is less than 0.5. Okay. In this case, we're interested in the probability that the random variable x is less than 0.5. Again, it's helpful here to actually sketch out, on the xy plane, at least let me draw out the xy plane, fxy, the joint PDF, would be a surface above the xy plane. I see along the x equals 0 line, this is going to be 0, but our PDF is only non-zero for x between 0 and 1, and for y between 0 and 2. Okay. And then, I'm not going to try and sketch what the surface looks like, but, I could pick any particular point at x equals 0, y equals 0, it's 0. Again, the surface is actually going to be 0 all along the x equals 0 line. And then let's find it at the x equal 1 line. At x equal to 1, it's actually going to be 1/2 of 1 plus y. So for y equal to 0, it actually have a height of 1/2, and then it's going to increase where y is equal to 2. It would be 3/2. So if you kind of visualize that surface, here along this line, it's actually going to increase linearly. Be something like that. Okay, and then for y equal to 0, it's actually going to just be 1/2 of x. It's going to be this straight line here. And for y equal to 2, it's going to be 3/2 x. So it's going to look something like that. Kind of a wedge with unequal heights here. So this is what the PDF looks like. We're interested in the probability that x is less than 1/2. So that's this region of the xy plane. And what I want to do is find the volume of that, of fxy in that region between, for x between 0 and 0.5 and y between 0 and 2. So I could work with the joint PDF and carry that integral out over y with respect integrating y between 0 and 2, but I'm actually just that's what I'm going to get there is just my marginal PDF. So in this case, I can work a little more easily working directly with the marginal PDF. I integrate x between 0 and 0.5. Again, in this case, because for x less than 0, the marginal is also equal to 0. And I didn't put those limits up here, but I really should. This is only non-zero for x between 0 and 1, and similarly the y marginal is only non-zero for y between 0 and 2. Okay, and let's see, 2x dx. So this is going to be x squared evaluated at 0 and 0.5. So I'm going to get 0.5 squared, or 0.25 for this particular probability. Okay. Let me actually clear the screen here now so we can look at the next part, the last part of this problem. Find the probability that x is greater than or equal to y, or equivalently the probability that x minus y is greater than or equal to 0. Okay, so probability x greater than or equal to y, or the probability that x minus y is greater than or equal to 0. And let me just sketch out the XY plane, I'm actually not going to try and do the 3D sketch of the surface that lies above the plane here. Sorry about my crooked axes there, but you know, this is the region above which the marginal PDF is non-zero, and so I want to find, you know, the region, the volume of um, of the PDF in this region where x minus y is greater than or equal to 0. So usually when you're working with inequalities, it's helpful to draw the line at which equality occurs. So that's the x equal y, or y equal to x line. So that's going to be this line. At x equal to 1, you know, that's y equal to 1. Now I have to figure out, you know, on which side of this line, you know, on this side or above it, the inequality is true, where x is greater than y. And you could just pick out some points here. Obviously here x is 1 and y is 1/2, so that is 1 point where x is greater than y. So again, we're interested in the volume or the volume under the fxy surface above this wedge. Okay, so this is the y equal x line, and so this probability then is equal to, you know, if you remember your calculus, I'm going to split this little area up like that, and my dy integral, which I'm doing first because I'm using dx strips, my dy integral will go from 0 to the equation for this line is y is equal to x, and I'm integrating my joint PDF first in this case with respect to y because I'm using dx strips, and then finally with respect to dx with x's going from 0 to 1. I could also do this using horizontal strips, but I would have to break, well, no, I wouldn't. Down here I could do this using horizontal strips with x going then from y to 1, and then y going from 0 to 1, I guess, in that case. Yeah, that looks right. But it's a little easier to visualize, I think, this way. So I carry out this integral. Actually, let me substitute in our PDF. I have 1/2 x 1 plus y dy dx. So first integrate with respect to y. I'll have 1/2 x y plus 1/2 y squared, evaluating that at 0 and x. So this becomes 1/2 x. This will become x plus 1/2 x squared, and evaluating it at y equal to 0, that is 0. So dx, I can pull the 1/2 outside, and multiplying x through, I'll have x squared plus 1/2 x cubed dx, integrating with respect to x, get 1/3 x cubed plus 1/8 times x to the 4th, evaluating at 0 and 1. So I'm going to get 1/2. Evaluating at 1, I'm going to get 1/3 plus 1/8, and then evaluating at 0, I'm going to get 0. So combining all these fractions, I get for a final result 11/48 for that problem. So I think that's it for this problem. Again, if you have any questions, please ask during the review session tomorrow.